Hello, this is Benjamin Mayinger, and I'm going to be showing off my block validation. I'm on the using ocean-going robots to observe wave conditions team, specifically the CS team, and I'm going to be showing you the pre-processed data logger. So, first off, I'm going to show that that has been assigned to me, and it has. And I have the block loaded here, and I'm just going to give a quick intro. So the pre-processed data logger provides a necessary functionality that allows our system to store and archive logs that contain basic statistical analysis about our data samples. This isn't just important for archival purposes, but also allows our team to view important statistical parameters that can be used for debugging. The Python script that creates these logs can be called from the command line using the following format: Python ppd _logger.py, and then the CSV file that you're trying to use. The script analyzes the input data set and logs statistical information about it in a separate directory named logs, where a new file is created with the same name as the input file, but with a text extension instead of the CSV. So let's get into our properties here. So for the interface going in to the block, raw decompressed sensor readings are logged in CSV files. These files contain a heading that describes parameters pertaining to the data. These parameters are as follows: time, angular acceleration, angular velocity, and displacement. There's 16 total there because each one of these is x, y, and z. And they are matrices of float values of 32-bit precision formatted as a CSV file. So let's quickly show that that's going on here. So let me actually show you specifically. This is where I will be showing off the code. Here is our Python script. Here are some example CSV files, and here is our logs directory. You can see it's empty. So let's show one of these CSV files. Here you can see the parameters pertaining to the data set, and then you can see they are all in float values. So these first two things are met. So now let's get on to the next one. It is required for the program to validate input and return error messages when bad input is given to the system. So we have to validate our inputs. Now let's actually do that. So we're going to look at the code real quick, see how this is actually working. So here we catch if there are too many arguments, and then we also catch if there are too few arguments, just looking simply at the arguments provided. And we throw error messages when that happens. So let's quickly do that. So we're going to call it too many, or I'll just call it with too few right here. So too few arguments are given. That actually provides you with how you want to call this. Now let's give it 2 CSV files, which it will not be happy about. And there you go, too many arguments are given, and it again tells you how you should call this. So now that we know that there are the right amount of arguments, we can actually try to open the file. So we do a try except statement here. So I'm going to provide it a file that doesn't exist, call it .csv, and here we see the provided input file does not exist. So that is also caught. So now that we know that we have a file that can be opened and it is being called correctly, we start creating our data. So we create a list of lists with all the parameters that we are trying to take in. Initialize an index variable, and then we open up our file and start reading it using this CSV reader, which is a very nice little tool here. And so we can just very easily iterate through the file, but before we can actually really read it in, we need to know if there's the proper amount of columns, so if the data is formatted correctly. So we're going to use this bad input, which as you can see only has 3 columns. So let's try that on. Add input. And here you go. Provided data doesn't match the expected data format, so it caught that. So now, there we have validated every bad input case there. So that confirms that this is also met. And then finally, raw sensor data is inputted into the subsystem as a CSV file with all the appropriate parameters, as described in the messages interface property above, and the file is inputted into this code block as a command line argument and read in using files Python IO. And as I showed earlier, we are using the command line, and we are using a Python file IO to do all this. So that is our input properties all met. So now let's get into the output. So after the input CSV file is read in and analyzed, a new log file is created storing statistical information about the input data. This file is written to a logs directory as a text file with the same name as the input file. The output log file contains the following parameters: sample size, sample duration, recording frequency, minimums for all variables, maximums for all variables, and averages, and outliers for all input variables. And it is important to note that the outliers must be listed with their respective times in the dataset. So let's do those first. And actually, let's also, this will be proved pretty quick. The system should print a success message if the program executes as expected with good input. So let's actually give it some good input. Do the first data set. So we get that success message. And now let's check if that was put in the right directory. So we have our logs directory, and if we look in here, now we have a text file that's been created. We can open that, and now we can actually see the format of our log. So we got sample size, sample duration, recording frequency, and I also want to quickly go back and show that all calculated statistics besides the sample size, which is an int value, are float values. And so if you look at this, we have an int for sample size, and then everything else is a float. Okay, and so we have our mins and maxes and averages for every variable, and then we have our outlier calculation, which I will actually go into the code for. So just very quickly, so we read in all our data, we closed the file. Now we need to give a proper heading for our new file that we're creating. So we remove the CSV, add the text as was described in the properties, open that in the logs directory, and then we start creating our log here. Sample size, of course, is just how many times we had to iterate through the initial file, -1 of course, because the first row is just the variable names. Sample duration is, you can just use the last timestamp and the first timestamp to find that. Recording frequency, that's done by dividing the amount of samples by the amount of time, and we can get a frequency in hertz. Then of course we have the min, max, and averages for all the variables. And then we get into our outlier calculation. So first we have a temp variable that we set to the output of this function. We pass in a list which gets passed to this function, and we can actually look at the definition of that down here. Well, this is the average calculation, very simple, just the sum of the list divided by the length. But here we have the outlier calculation. We're using a simple z-score outlier calculation, wherein the threshold defines the amount of standard deviations a value needs to be away from the mean to consider it an outlier. We then create this, we have an outlier list, and we append to it when we find something that is beyond the threshold. And then we return that list back. So temp is now that list. If temp is empty, the length of temp is, if it's not empty, greater than 0, then we actually iterate through it. So we show each outlier, the value of the outlier, and we give the timestamp, which is when that outlier was actually recorded. And if we don't find the outliers, we just say no outliers find. So let's look at what's going on here. We have no outliers found. For these first variables, we have some outliers here. And just to show that this is working as expected, I have another CSV file where I just kind of sprinkled in some outliers. So we'll run that. So let's do this, and then we'll do the other CSV. Run successfully. Let's open that up. And everything looks the same, but now you can see we have an outlier here, and yeah, one here as well. So outliers being calculated properly. And that's basically all that's going on here. And let's go back to our property list. So all of these are looking good. We have all the proper parameters in our log file. They are of the right type. We have a success message. It's put in the right directory, and then finally code control transfer log values stored in text file and passed to the user interface module, i.e. the proper logs directory. And we saw that we were using Python's file.io, and we do have that directory, and they are being put in there. So that is basically it for the pre-processed data logger. I just also wanted to say that I tried to make this look nice, formatted nicely. I have a lot of comments explaining exactly what's happening. I'd like to thank you for spending the time to watch my validation. I hope it wasn't too boring. Thank you.